So the last thing we're going to talk about here is how we can connect our ideas back together a little bit, where a concept called effective rate or effective annual yield looks at the interest rate we'd have to have following a simple scheme to equal out over 1 year to a compound scheme, where in particular we kind of assume that the interest is going to compound more than once per year, otherwise it's just a simple scheme in the course of 1 year. But to do this, we have the formula y for the rate is equal to 1 plus r over n raised to the power n whole thing minus 1. And to get that, it's actually a pretty simple derivation, because what we're assuming is that the compound rate, p times 1 plus r over n raised to the power n for a single year, remember, is equal to the simple rate for 1 year, where the rate we want to get is what we're calling y. So what we can do with these things, both having p's on each side, is just kill the p's and then subtract a 1. And that gives us y is equal to 1 plus r over n raised to the power n minus 1. Very, very simple algebra under that assumption. So let's say that we have an account here with a rate of 6.75. So r equals 6.75% and n is equal to 12. It compounds monthly. So y, I'm not going to write down the formula a third time, would end up being equal to 1 plus the value r, 0.0675, divided by, I made a mistake. Make our lives a little bit nicer here. Not compounded monthly for once. We're going to do something that compounds quarterly. It's going to be 4. Sorry about that. In this case, we would have that we are dividing by n equals 4, and raising to the power 4. Maybe I should have written the formula again. So this is what I get for trying to take a shortcut. And we're subtracting 1. Plug all that stuff in as you need to, and we're going to get a value here of about 0.069. That is, if we want to have a simple interest rate that equals in 1 year a compound interest rate of 6.75 that compounds 4 times in that time period, it needs to be about 6.9%. Where generally, for reasons that hopefully you're able to tell you if you don't need to run the numbers yourself, the smaller n is, that is, the less frequently the value compounds, the closer the effective rate is going to be to the actual rate. Whereas if I kept with that being 12 by mistake, we should see that this is a little bit further away. We need a little bit higher of an interest rate to keep up. And if I had picked 2, this would be a little bit lower, a little bit closer to 6 3/4. But that's about all we have for this section, 8.4. And that's about all we have for the week. Next, we're going to keep moving on here, and we're going to talk about more kinds of investments. I'll see you in there.